Assalamualaikum everyone. In this video we'll talk about proper fractions. Okay, in the previous video we saw a little about proper fractions. In this video we'll talk about proper fractions in detail. Okay, so here proper fraction, a rational fraction f of x by g of x is called as a proper fraction if the degree of g of x is greater than the degree of f of x. Okay, any fraction will be a rational fraction because any fraction which is in the form of f of x by g of x, anything which is in the form of f of x by g of x is nothing but a rational fraction, where f of x and g of x are nothing but the polynomials, right? So this rational fractions, if the degree of g of x, that is the denominator, if the degree of denominator is greater than the degree of f of x, that is the numerator, then that such type of questions falls under proper fraction. Simple. The degree of the denominator is greater than the degree of numerator. That's it. Now from these examples, let's try to find out which is proper and which is improper. Okay, let's try to pick the proper ones. Here 3x by x minus 2 into x plus 1. Here the degree of numerator is what? 1, right? The degree is 1. Now here if you multiply x into x will be what? X square. So the degree of x square means is what? 2. So here 1 is less than 2, right? This is your denominator and this is your numerator. So the denominator is greater than the numerator. So yes, this is a proper fraction. Okay, next 1 by, here see, 1 means I have got no variable, that means the degree here is 0. Now x into x will be x square again. So x square, degree of x square is what? 2. So 2 is greater than 0, right? Here this is the denominator, this is the numerator. So denominator is greater than the 0. The degree of denominator is greater than the degree of numerator. So yes, this is a proper fraction. Here the degree here is what? Nothing is there, we consider as 1. So x power 1 is, the degree is 1. Here x plus 4 whole square. See, so a plus b whole square formula, we expanded, it will be x square, right? The whole term, no, not the whole term, I'm just saying the first term. A square is nothing but x square. So x square mein degree is 2. So 2. So this 2 is greater than 1. The denominator is greater than numerator, right? So yes, even this is my proper fraction. Next here. See here clearly the degree of x is what? 1. Numerator is 1. So 1, here the highest degree is 2. So 1 is less than 2. The numerator is smaller than denominator. Yeah, this is a proper fraction. Here see. Here the degree is 2. Here it is whole square, right? So x square. But this is not it. After this we are going to multiply these terms with this term, right? So x square will be multiplied with x. If we expand this, x plus 2 whole square, it is a plus b whole square. So a plus b whole square is nothing but a square plus b square is nothing but 4 plus 2ab, matlab 4x, right? Now this term will be multiplied with this term again, x plus 1. So if you multiply x square with x, you will get what? X power 3. So the degree is here 3. So 3 is greater than 2, right? So the denominator has more degree than the numerator. So denominator is greater than numerator. Understood? Now next, that means this is a proper fraction. Now next, x square, here square in the numerator, denominator, x into x square is what? X cube, right? That means the degree is what? 3. So 3 is greater than 2. This is denominator, this is numerator, right? So that means even this is a proper fraction. Next, here in the numerator I have got 2. The degree is 2. In the denominator, again this thing, a plus b whole square will give you something like this. We have got square term. Next, multiplying this with this, x plus 1, you will get what? X cube. same, this and this are same, right? The denominator is the same here. So the power is what? 3. 3. So 3 is greater than 2. So this is a proper fraction. Got? Now next. Here the degree is what? The highest degree is what here? 2. 2. Here if you multiply x with x, you get what? X square, right? This degree of x square is what? 2. The degree is 2. So 2 is equal to 2. So if you see, this is not greater. The denominator is equal to the numerator. So in this case, it is not a proper fraction. This is not a proper fraction. Okay. Next. This one. The degree here is, in the numerator, the degree here is 4. In the denominator, if you multiply this x square with x, you will get x power 3. So the degree is here is 3. So this is my numerator. This is my denominator. So the numerator is now greater than the denominator. But what I want, the denominator should be greater. Here the denominator is smaller. So this is not a proper fraction. This is not a proper fraction, this one. Next one. 3x cubed. The degree here, the highest degree or the degree here is what? 3. In the denominator, if you see, x into x square will give you what? X cube again. So cube is nothing but 3. So 3 is equal to 3. The denominator and the numerator both are equal. So this is not a proper fraction. Right? So now, why are we seeing this? Why are we differentiating a proper fraction from all of this? Why are we picking out a proper fraction from all of this? Because see, if you know all the formulas in mathematics, if you know the formula, if you know the procedure, but you don't know which formula to apply on which question, then you knowing the formulas and procedure is of no use, right? So we are identifying a proper fraction from these rational fractions. Okay, these all are rational fractions because everything here is in the form of f of x by g of x, right? So these all are nothing but my rational fractions. From that, these are the proper fraction and these are the improper fractions. Okay, now proper fraction is done. Let me just erase this all. So now proper fraction is done, right? Let's have a look at the procedure of how we are solving these problems. Okay, the steps that we are going to follow. Step 1, factor the bottom. Bottom means nothing but g of x, the denominator. Okay, the denominator. I need to what? Factorize the denominator. Okay, so suppose if you consider this example, see, here I have already given the factor x by x plus 4 whole square. This is the factor which is repeating 2 times. It is like x plus 4 into x plus 4. I've got 2 different factors here. But if you consider the example to be like this, x square plus 2x plus 1. Okay? Here we need to factorize. Okay, if the question is suppose like this, we need to factorize here. If we are given a polynomial, right? We are given a polynomial, we need to factorize this polynomial in order to get the factors like this. Okay, so if this is given, suppose if the question is like this, so we can skip the step 1 because the factors are already given. So we are going to skip the step 1, we'll directly go to the step 2. Okay, if the question is like this, then we need to perform factorization in order to get different factors. Then we can go for the remaining steps. Okay, so next, write one partial fraction for each of those factors. Suppose I've got 2 factors. Suppose these are my factors. If I got 2 different factors, consider, suppose it is x by x plus 4 and x minus 4. Suppose these are my factors. For this factor and for this factor, I need to write partial fractions. Okay? If I've got one more factor, suppose x plus 1. So for this, even for this, I need to write my partial fraction. जितने भी आपके पास factors रहेंगे, उतनों के लिए you are going to write partial fraction for each. Let me show you. Let me erase this. Suppose, consider this question, 3x by x minus 2 into x plus 1. 3x by x minus 2 into x plus 1. Here if you see, we have got 2 different factors. One is x minus 2 and the other is x plus 1. Now I will be writing 2 different factors for this. 2 different partial fractions for this. One is for x minus 2 and the other is for x plus 1. How will write? Here I'll get a constant. I don't know the value, right? So I'll be having a constant. Here is the another constant. So this is one partial fraction and this is one partial fraction. This is because we have got two different factors. We will be having two different partial fractions for it. Okay, write one partial fraction for each of those factors. One partial fraction for each. One partial fraction for each. Right? Next step. Multiply through bottom so we no longer have fractions. That means what? I need to take the LCM here. LCM will be x minus 2 and x plus 1. This is as it is. X minus 2 and x plus 1. I'm just writing the denominators here. Okay, I'll write the numerator as well. A into x plus 1. After taking LCM, we have to cross multiply here, right? LCM is nothing but like this only. So here, these two terms are similar, so I'll cancel this out. So I no longer have a fraction. This is no longer in the form of f of x by g of x. Now it is a simple polynomial. Okay, this question, after I cancel out the denominator, I'll no longer have a factor. I'll just have a polynomial. So it will be something like 3x is equals to, after cancelling out, a into x plus 1 plus b into x minus 2, right? It is not a fraction. It is not in the form of p by q. It is not in the form of f of x by g of x, right? So it is a simple polynomial. Now next step is step 4. Now find the constants a1, a2. If I've got a1, a2, I'll find a1, a2. If I've got abc, I'll find abc. This is a constant. This is a constant. I need to find the values of this. How we are going to find the values of this constants? We have got two different methods. One is finding the roots. Okay. Suppose this is a factor given to me. X minus 2 is a factor I have. How will I find the roots? By equating this factor to 0. X minus 2 is a factor. I'll equate this to 0. Okay. So from here, x minus 2. The 2 is subtracting here. Goes to the other side. Adds. Right. It is on the LHS side. If it goes to the RHS, it adds. So x will be equal to 2. Here x as it is. This 2 is going to the other side. So it will be minus 2 ki jagah, it will be plus 2 now. Equal to other. So this means what? Now the value of x is 2. So wherever I find wherever I find x in the equation, I'll substitute 2 in place of it. Okay. So this means what? 2 is the root of x. Okay. 2 is the root of x, or 2 is the value of x. This is how we find the roots, right? What do you mean by root? If see here, this was my factor right here. If I substitute this 2 now in this equation, I should get 0. Matlab LHS and RHS should be equal to 0. If I substitute 2 in place of x, 2. I already have minus 2. So 2 minus 2 is equal to 0. So LHS and RHS are satisfying here. Matlab if I substitute the root value in the equation, then I should get the answer as 0. Only then it will be a root. ठीक है. अगर मुझे यहाँ पे if I don't get 2 here, if I get 3 or something else, if I don't get here 0, if I get minus 1, if I get 1 or anything like that, 2, anything like that, if I don't get 0, that means this is not the root of this equation. Okay, I think I'm clear with the root. Now this was one method, finding the root. Okay, so here what we do, this 2 we got as a root, right, of x. So we'll substitute this value, x value, in this equation. Matlab wherever I find x in this equation, I'll substitute 2 in place of it. Okay. Now next, this was one method. Another method is comparing the coefficients. If suppose this method does not work in the sense what? See here. Suppose this is my factor, x square plus 1. Suppose this is my factor, x square plus 1 is my factor. I'll equate this factor to 0. Next, here I'll send this 1 to the other side. 1 is being added here because I want only the value of x. So first I'll send this constant to the other side. So here it is adding, goes to the other side, subtracts, right? So this will be x square is equal to minus 1, right? So next step, this is minus 1. Then next I have a square. I only need x, I don't need square. I only need x. So I'll send the square to the other side as well. So it will be under root. Square on the other side goes to the other side, becomes under root. So it will be under root of minus 1. So if you see here, I will not get the value of this number. It will be an imaginary number. Okay, it will be an imaginary number. I won't get a value of this. So in such cases, we won't go for this equating method. We won't find the roots like this. We instead compare the coefficients. Okay, I'll just erase this and show you how. Second method, comparing the coefficients. Okay, so here if you see in this equation, we'll find the variable with the highest degree. Okay, we'll try to find the variable with the highest degree. So here, see, the highest degree is what? I've got a variable x here. The degree is here 1. Moving on, I have again a variable x has degree 1. Again, moving on, see here, I have a variable x having degree 1. So if you see in this equation, we have got only one variable, that is x, and it has the degree, highest degree as, or the degree as 1. The variable here is x. So now what we do is we compare the coefficient of this x. Okay, we compare the coefficient of this x in this entire equation. Okay, so here in this one I've got x here, right? So the coefficient of x is here what? 3. I'll write here 3. Now after that, moving on the RHS, I've got x here. The coefficient is what? A. Moving on, I don't have x. The next x, here I have an x. So the coefficient of x is what here? B. Plus b. I have a plus, so plus b, right? This is how we do it. After that, if we know any one of the values, we substitute and we'll get one constant. Okay, this is how we equate the coefficients. We compare the coefficients. Suppose if the highest degree, suppose this was the equation, x cube plus 2x square plus 1 is equal to 4x. Suppose this was a question. This was the equation. So here if you see the variable with the highest degree is x cube, right? So now we compare the coefficients of x cube on both the sides. Okay, this is how we do it. This is the second method. If the first method fails, we go for the second method. Now after these two methods, after performing these two methods, we'll get all the constants. We'll get the a, we'll get b. If I have c, d, other constants, we get that as well. Now after that, after finding all the constants, the step 5 is to substitute the values of the constant to get the final answer. Where do we substitute these constants? Here, in this question, from where we started, right? This was the point where we decompose this question into two partial fractions, right? So here we substitute the value of a and b. Suppose the value of a and b we got as 1 and 2. Now this one is my partial fraction and this is my another partial fraction. Okay, this is the procedure that we are going to follow. Okay, I think I'm clear with this. I'll repeat it again. First step is to factorize the denominator. Okay, if the factors are directly given, we don't need to factorize. We can jump to the second step. But if the factors are not given, if I'm given a polynomial, then I'm going to factorize this. Step 1 done. Step 2, write one partial fraction for each factors. After getting the factors, what we are going to do? We are going to write separately the partial fractions for each of them. Step 3, multiplying through bottom, so we no longer have fractions. Matlab here taking the LCM, nothing but taking the LCM, so we can cancel the denominators. The aim here in the step 3 is to cancel out the denominators. Okay, now next, now find the constants. We are finding constants with the help of two methods. One is finding roots and the other is coefficient. In some cases we can use both the things together. Okay, first we can find the root by equating it, and then next we can compare the coefficients. Okay, then step 5 is after we get the values of all the constants, we substitute the values in this equation or in the final partial fraction to get the answer, the complete answer. Okay, I think I'm clear with this topic. In what we saw the partial fraction, we identified some partial fractions, and then we saw the method or the procedure. This method and procedure is for all the types. I mean, I told in the previous video we saw about types, right? Type 1, type 2, type 3 and type 4. For all the types, this is the procedure, common procedure. Okay, for it, be it be a proper fraction, be it an improper fraction, the procedure is this. Okay, so that's it for this video. I hope you all understood. Thank you.